Hello and welcome to PyData Global 2021. My name is Natalie and I'm very happy to be here and be your host for this session. I would like now to welcome Stavros Papadopoulos. Can you please, do you mind?
Yes, Stavros Papadopoulos, that was a good attempt, Natalie.
To our session, and he will talk about TileDB and the new data economics. Prior to founding TileDB in February 2017, Dr. Papadopoulos was a senior research scientist at the Intel Parallel Computing Lab and the member of the Intel Science and Technology Center for Big Data at MIT CSAIL for 3 years. He also spent about 2 years as a visiting assistant professor at the Department of Computer Science and Engineering of the Hong Kong UST. And with that, I'll give the floor to Stavros. Thank you so much for joining us today.
Thank you, Natalie. Thank you, everyone, for attending. So I'm going to share my screen for the presentation. So I'm going to talk about a topic that is not as technical as pretty much every other single presentation and webinar we have given in the company. Our company is extremely technical. This is a presentation that I thought I would give for the entire data community because I think these issues should concern everybody, and especially the PyData community. And then at the end, I'm going to present the company. So I'm going to do it in reverse. First, I'm going to talk about some more general stuff, and then I'm going to tell you what we do at TileDB and how we are addressing these issues. Okay, so when I talk about data economics, I mean effectively 3 things in the context of my presentation. First, the production of the data, and specifically the format the data is produced in and where it goes, where is it stored. This is what we should be focusing on when it comes to production that affects data management and data computations down the road. The second thing is distribution. So who has access to the data? What is the means of the access, and how can we make money out of the data and compute? Because there are a lot of organizations that are monetizing their data. And finally, how do we consume the data? What tools and where does the computation happen? So these are the data economics, at least in my mind, in this presentation. So what is the problem with the entire community? This is holistic, guys. It's not about a single vertical. It's across the verticals, across the domains. And some domains are extremely different, or at least seemingly different. They're suffering from exactly the same problems. So the problem is that all data management solutions, all tools, focus on consumption. That's it. Like predominantly, when we try to create solutions, we focus on consuming the data and the computations. The computations, how scalable they are, where do they run, the cloud, on-prem. So this is the problem that most of the solutions, at least I know, especially from the database domain, they focus only on this and they completely ignore the other two. So at the general level, the problem is that this leads to the data being produced in inefficient formats only because production is not on the radar for us. Somebody produces the data in some different formats, and then we're trying to wrangle the data into our format or into some processable format so that we do the analytics. Most formats are domain specific. The domains don't talk to each other. The bioinformatician does not talk to an Earth observation scientist. This creates a lot of problems. I'm going to explain a couple in a bit. The distribution and especially issues around sharing and collaboration are an afterthought. This is not what the databases are architected around. Usually they try to incorporate features later. Most tools are domain specific. Again, each domain works kind of separately on their own data with their own tools, and they're missing out on more generic tools in data science, for example, or in databases that could be a great fit for them. And a lot of ETL is involved, a lot of conversion, transformation, copying of the data from one format to another in order to make meaningful analysis on the data. So that's the general problem. I'll give you a couple of examples to make my case. For example, genomics. So genomics, the data comes in these weird formats called FASTQ, BAM, and VCF, the predominant formats. These are produced by the sequencers. Then this data is usually stored in some cloud buckets or FTP servers. You will be surprised. And some of the solutions are like Dropbox with HIPAA compliance. So they're file managers because they work on files. They're not databases. They have not incorporated database solutions yet. And the analysis is done with domain-specific tools like BCF tools and GATK, not with the general data science tools that you would see at PyData, for example. Another application is marine traffic, so AIS data, ship locations on the map. The data is in CSV files, storage in cloud buckets, distributed and sold. This data can be sold as files. So you see the correlation kind of. And the analysis and visualization is done with specific tools, domain-specific tools like GIS. Finance and specifically historical data, data in text files, storage in cloud buckets, distributed and sold as files. You see the pattern here and how different these domains are. They suffer from exactly the same problems. And the analysis with some database or some data science tools, these are a little bit more general, I would have to say, and some domain-specific tools too. And then LiDAR, again, yet another domain. The data is in LAS files, domain-specific, storage in cloud buckets, distributed as files with metadata, and analysis and visualization with GIS tools. So you see the pattern is there, and I'm going to elaborate on the problems in a bit. So let's take each problem one by one and understand what the actual issue is. So for the production problem, again, there are some sources, the organizations that are producing the data in isolation from those that will consume the data. And the data is in the formats that they choose. They choose the formats. They don't care about what kind of analysis you're going to use because they own the data, they own the format they choose, usually a legacy format. It's usually something that was chosen ad hoc 50 years ago, and they continue to use the same thing. Then this is dumped somewhere because it's a file. So usually now some object store on the cloud, which is cheap because this is a lot of data, or some kind of a file manager. Then there is a lot of ETL because that format is not useful. So there has to be some ETL. And then, the users create their own analytics infrastructure in order to consume the data. So what is the problem? The problem first is the ETL. It's a big bottleneck to try to convert petabytes of data in your format only to be able to slice the data. And also this analytics infrastructure, because the format is custom and because there is no holistic approach, you build it on your own. You will be surprised how many different institutions are building the same infrastructure, but in different ways, custom and in-house. And this is costly and time consuming for the organization. The organization's IP is not in building the infrastructure, is in what comes through the insights from the analytics. So these are the problems created by producing the data in the wrong format. In terms of distribution, there are two problems. Let's take the first one. Again, the data always in some custom format. This goes into some bucket or some marketplace. There is an advent of marketplaces in the past couple of years. So they store the files and they are the distributors of the files. And then there's an organization, they need to take the files, download, wrangle, build infrastructure, so store the data in their own buckets, in their own infrastructure, build their own tools. And this happens across N organizations. So there are 1,000 organizations using the same files. They will do that 1,000 times. For example, there is an AIS company, distributing their CSV files. Every single organization using those files will have to download the files, wrangle in some more meaningful format, and create an infrastructure for queries. They do the same thing. So the problem is here. There is a lot of reinvention, and this is, again, very, very costly, only because the organizations distributing the data, they're distributing files. They're not distributing an analytics infrastructure. The second problem is when some organizations, the data owners, again, they gather the files or they're producing the files, but now they are building something more. Okay, they're building their own infrastructure. So they're saying, okay, we're going to curate, for example, financial data, and we will build an actual infrastructure, right, to sell the data and distribute this data. And then the users just consume the data, just queries, no more infrastructure, just queries. So this is moving towards the right direction, but here are the problems. The data owner bears the cost, right? If there is a financial curation company that distributes the curated data and they want to build infrastructure, they will have to pay for it. They will have to build it. They will have to pay for it, and they will have to pay for all the users using this infrastructure. And these economics are wrong, right? They are wrong for those data owners, to the point that the data owners go back to the previous slide, which means they distribute the data in files in buckets, right? That's the problem. This is difficult to pull off. And also, if there are 1,000 different data owners from 1,000 different domains, they need to build the same infrastructure to service their data, because the data is not as different as you might think that it is. I'm going to get back to this in a bit. And finally, the consumption problem is that, again, tons of files, different formats, you put them in some storage bucket or some server, and then each of the groups within the organization, so now suppose that this is within the same organization, they have to take the data from whatever form the organization is storing the data, and use any tool. It could be Python, it could be Spark, it could be Dask, whatever they want. But then if there is another group, they will have to, again, download, copy the data, wrangle the data, and use another tool. Only because the tools cannot coordinate on the same data. And only because this infrastructure, the data lake, right, that is being promoted, is just a file manager. And if it is a file manager and the organization has 100 groups with 100 different tools, they will have to build the same micro infra within the organization. Again, you cannot imagine how many people we've seen doing this, how many organizations. We have even talked to groups in the same organization that don't talk to each other, and they have built different micro infrastructures. So the problem again is here. This is inefficient and costly, and there is a lot of reinvention as well. And we're talking about the same data, right? Like infrastructures that access the same data. So how do we solve this problem? And again, this is for the community, for anybody working on this topic. And again, our message here is approach data economics holistically and across the domains. Like, don't think only about genomics, don't think only about Earth observation, holistically, right? There have to be so many similarities that we need to approach this holistically. So here's a proposal, and then I'm going to tell you how TileDB is actually solving this, how TileDB is an instance of this solution. So first of all, we need to depart from the formats, folks. We need to build something. We need to produce the data directly into something that is analysis ready and something that is universal. And by universal, we mean that it can capture all data types and all tools will be able to consume efficiently. So a universal format for all data. Second, we need a data management platform. Again, universal. If it works on a universal format, we can build a single platform, whether it is genomics or geospatial, a single platform that addresses this on the same data model, And this can do pretty much the governance, the distribution, the analytics, everything. And then this will enable any number of users, any number of organizations to use any tool with any scale without building infrastructure. So the benefits are clear. No ETL and copies anymore. There's a single copy of the data in an analysis ready way. So there is no need to wrangle this anymore. You just slice it. The second is that one infrastructure, any backend, any scale, this has to be part of the data management platform. That's its job. Then unified governance, you build one authentication mechanism, one access control mechanism, even one marketplace for all these applications, for all these data types. And again, common across all. And I'm going to tell you exactly how you can pull this off in the next slides, and the marketplace that I mentioned. So this is a solution. This is how it should look like. It addresses everything from production to the universal format, to distribution, the unified governance, to consumption with any tool. That's a holy grail. So how did we solve it? First, we chose multidimensional arrays as the universal format, and it is universal. I'm going to show this to you in the next slide. We were able to capture tens of applications already, and there are so many others waiting just with this format, very, very efficiently. Second, we build the platform. We build a single platform with all the benefits that I mentioned in the previous slide on arrays. Since we unified the model, we were able to build a unified infrastructure. And then we have extreme interoperability with all tools, anything in the PyData ecosystem, so that there is no copying, all with zero copy techniques. So the benefits, again, multidimensional arrays for the universal format. You have the governance and collaboration here, the built-in marketplace is here in a pay-as-you-go manner. The cost is shifted to the consumers. That's how TileDB works. TileDB manages all the infrastructure at crazy scale. If you're a data owner, you just put the data in the TileDB format, you register your data with the platform, and then you may have millions of users running on the TileDB infrastructure, serverless, very easily, without the data owner paying a single dollar for infrastructure. That's the way we solve this problem. We shift the cost, we crowdsource the cost of distribution rather than forcing the data owners to build the infrastructures to serve their data. And we do it, we take it to the extreme. You can share data, you can share code, you can sell data, and you can sell code, runnable code. So these are aspects of TileDB that will be left to a different presentation, but I'm just giving you an idea of an instantiation of a solution to this data economics problem. So a few more details now about TileDB, and then I'm going to conclude. We will have time for questions. So this is how the multidimensional array data model looks like. There are two flavors, dense and sparse, for those that have used structures like this. TileDB unifies this. It's not like HDF5 or ZAR. It has the same features and then some, and especially a lot of work on the sparsity, right? We capture sparse data extremely efficiently. Again, we have separate webinars for that. If you want to look into the format, if you want to look into the storage engine, we have everything online. We have a lot of materials. Regarding the universal platform, the universal database, here's how we built it. Imagine at the bottom any backend. TileDB is not just cloud. It is cloud native, but it's not cloud only. You can use it anywhere. You can use it on the laptop. You can use it on your on-prem infrastructure. It is not bound to a particular cloud vendor. Then at the very top, think of anything. We have 7 APIs and growing. We have integrations with Spark, Dask, MariaDB, Presto, Trino, you just name it. And if there is a popular package, popular library that our users and customers are using, and they want the integration with, we integrate very, very efficiently with zero copy techniques and everything. And we have two offerings to solve this problem. First, it's about the format and the storage engine of the format. It's called TileDB Embedded. It's a library. It's not a server. You can find it on GitHub over here. And this deals with everything arrays. The format, versioning, time traveling. It has a lot of sophistication just in the open source. And this will always be open source. And then the actual platform, we call it TileDB Cloud. It works both as SaaS as well as on-prem. And this is what adds more to the storage, which is the authentication, access control, serverless SQL, user-defined function, task graphs. Again, a lot of sophistication, a lot of features, but again, the solving the problem that I mentioned in the previous slide. So that's it about the technology. Again, I promise that I'm going to keep it high level and I'm not going to get too technical, but all the technical materials are online. And I'm going to conclude with a few words about who we are and how to find us and everything. So TileDB got spun out of a research project that I have built at Intel Labs and MIT between 2014 and 2017. It has deep roots at the intersection of high performance computing because of Intel, databases because of the database group at MIT I was working with, and data science because, contrary to others, I talk to a lot of scientists across pretty much every domain you can think of. And this is what gave rise to the universality of TileDB. We're well capitalized. We've raised some, we're VC backed. We have some very important VC firms supporting us. Currently, we're 14 growing. We're hiring constantly, and we have a lot of traction across multiple domains, from telecoms to hospitals to pharmas and so on and so forth. So with that, I would like to thank you so much for the opportunity. Please know that we are hiring. Apply if you found this interesting and or intriguing, and I'm happy to answer any questions.
So we have a question from Mike. So does TileDB arrays work with NumPy arrays in some way?
Yeah, absolutely. So TileDB embedded, the storage engine, is a C++ library, but we have a Python API. It's called TileDB-Py. You can find it on GitHub. You can find everything on GitHub. And this has tight integration with both NumPy and Pandas. When I say tight, I mean we bring the data into NumPy and Pandas with zero copy techniques. So it's as fast as it gets. You're going to get in Python the same performance you get in C++. Thank you very much. You can always find us by browsing our website at tiledb.com. You will find all the materials there. We're very accessible. We have a Slack community. You can join it and you can ask questions. And you can find me also on the PyData Global Slack community channel. If you have more questions, if you're going to set up meetings, we're very open to that.
Thank you, Stavros, for your talk and being part of PyData Global 2021.
Thank you. Bye.